The next problem in your mid-quarter 3 packet is problem number 5, which is asking you to solve the closure problem 5107. Now in this problem, if this were an equals, then you would just factor it and set each factor equal to 0, but it's not. It's saying that this quadratic is actually less than 0. So there's going to be a parabola somewhere, and when I graph that parabola, I'm only going to be looking at the values where it is negative or less than 0. So first, let's look at this algebraically, and then we'll look at it graphically. Algebraically, I would factor, and if you don't remember how to factor, I do have a video in chapter 5 on Moodle, but I'm just going to do a quick factor here. What we usually do is we do this x, so I know that they have to multiply out to be negative 15x squared, and they have to add up to be negative 2x. So I try to think of all the combinations that when I multiply them together, they give me negative 15, but when I add them, they're going to give me negative 2. So what I came up with was 5x and 3x. And then I think about if this were a rectangle, and I was finding out where x squared would be here and negative 15 would be here, I need to find what this side is and this side is. So I have my negative 5x, my positive 3x. This is going to have to be x by x to make that little one x squared. So this is going to have to be a negative 5 because x times negative 5 is negative 5x. And since this is negative 5, this will have to be positive 3 to make it equal negative 15. Also, this has to equal 3x. So there they are, my factors, x minus 5 and x plus 3. Okay, so now I know that when I take x minus 5 times x plus 3, I have to have a negative answer. Now, some of you think about that as far as, one would have to be negative and one would have to be positive. Some of you look at a number line, and your boundary points would be 5 and negative 3. And so you graph those, and you pick regions to test. So this would be region 1. This would be region 2. And this will be region 3. And I'm just going to test and see when I pick a number in there for x, when this is a true statement. So let's start with region 1. I'll pick the number negative 10 because that's down here in region 1. So is negative 10 minus 5 times negative 10 plus 3 less than 0? Well, this is negative 15, this is negative 7, so no, that's going to be a positive answer. So now I'm going to pick something in region 1. How about 0? Let's let x equal 0 because that's in region 1 between negative 3 and 5. So is 0 minus 5 times 0 plus 3 less than 0? Is negative 5 times 3 less than 0? Why, yes, it is. So region 2 is going to get shaded. And just to be thorough, I know that this isn't going to work already because region 2 worked, but I better check anyway. This time I'm going to let x equal 10 because that's up here in region 3. So is, let's see, 10 minus 5 times 10 plus 3 less than 0. That would be 5 times 13. Nope, that's going to be a positive answer, so it's not. So my answer is going to be that x is between negative 3 and 5. How we write that algebraically is I put the x in here, negative 3 down here. I put the smaller number goes down here, the larger number goes up here, and it's less than. Was there an equal to sign in that? No. So strictly less than. And this is how I would write that algebraically. How I would draw it on a number line I would have negative 3 on my number line and 5. And there would be an open circle on 5, an open circle on negative 3, and I would shade everything in between. So any of those numbers would work.